Video will cover the Year 10 Indices in Interest Applications test preview. These are the sorts of questions you should expect to see at an A and B level. I'll put some time tags in the description below so you can skip to question numbers or question types. But these are the index laws that we went through in the fundamentals video. If you haven't watched that and you're unfamiliar with them, you should probably go back and watch that one. Otherwise, it's probably worth just pausing the video and making a note of these and some of the examples. They'll help you work through this unit. These questions are a mixture of division and multiplication. So there's a few different ways of tackling these. We're going to have a look at how we can unpack this a little bit. So what we might do is, in our first line of working, we usually like to tidy these up a little bit. So let's have a look at what we can do. Let's tidy up top and bottom. So I've got 6 times 1 up here, so there's a little 1 sitting in here, so I've got 6, and then I've got c to the 4 plus 2, which is 6, and that's all going to be over 15 divided by 1, so 15. I'm not messing around with the numbers just yet. And then I've got c to the 1 minus 7, so c to the minus 6 down the bottom down there. And so what I can do now is I can shuffle these around a bit. So I might simplify the fraction while I'm here. 3 will go into 6 twice. We'll go into 15 5 times. I've got c to the 6 at the top, and I can bring that other c up, and when I do that it becomes a positive 6, and now those are being multiplied, so it's 2 over 5, and I get c to the 6 plus 6, which is 12 at the top, and this one is being finished. Question B, let's tidy up those brackets first. So I've got 4 at the top there, and then because I've got brackets, I multiply my indices. So I've got d to the 2 times 3, which is 6. Down the bottom, I've got minus 12 times 1, so I've got minus 12. And then I've got d to the 5 plus 4, which is 9. And then I like to bring my indices up just so that it's nice and clear what's happening at the top there. There is another way to do it, but let's do that. So I'm going to simplify my fraction. I've got 1 over minus 3, and then I've got d to the 6, d to the minus 9, and then I'm just running across the top there. So if I've got d to the 6 minus 9 makes d to the minus 3, and it's over minus 3. And then to make that a positive indice, because the question tells me that I've got to make it positive, the final answer to this one is 1 over minus 3 d to the 3. Question C, let's have a look at this. Let's tidy up those brackets at the top up there. Remember that that little 3 applies to this 2 as well, because that 2 has actually got a little indice of 1 that we don't bother writing up there. So that means that this one is going to be minus 2 cubed makes minus 8. And then I've got c to the 5 times 3, which is 15. And that's all over 9. C to the 3 times 4 is 12. I said in the last question that there's another way of doing this. Some people like to work vertically. Okay, so what they do is they'll have a look at this one and they'll leave the fraction as it is, minus 8 over 9, and then they say c to the 15 divided by c to the 12. 15 minus 12 is 3, so it's c to the 3. And that's a great way of doing it. It's very efficient with these questions. When we start getting into these harder ones over here, I find that my way is a little clearer for me, but you do it whichever way you prefer. Question 2. Let's simplify these. We can keep these ones in negative indices if we like, so that's great. We'll save us a step. Let's expand these brackets. That leaves me with m to the 5 times minus 3, m to the 2 times minus 3, and now I've got 4 to the power of 3, which we'll solve in a minute, n to the 1 times 3, m to the 5 times 3. Fantastic. Let's work down the row. Let's sort out those numbers first. 4 cubed is 64, so we'll pop that out the front. I'm going to work in alphabetical order, but it doesn't really matter. I've got m to the minus 6 plus 15 leaves me positive 12, doesn't it? Positive 9, rather. Better. I'll try that again. M to the minus 6 times m to the 15. Minus 6 plus 15 gives me positive 9, and that's supposed to be a 9. And then I've got n to the minus 15 plus 3, which is minus 12. Trying to solve things ahead of myself. There you go. Final answer. Question B. Let's have a look. We've got n to the 4 times negative 3n to the 5. Wow, we've got lots going on here. Let's sort out those brackets first. So I'll leave these just roll down for a minute, and we'll sort them out in a minute. So I've got 5 squared, which is 25. I've got n to the minus 4 times 2 makes minus 8. And I've got v to the 1 times 2, which is 2. And now what I'll do is I'll start cleaning it up. Let's go with the numbers first. So we've got 1s, and then we've got a minus 3 and a 25 there. So minus 3 times 25 makes minus 75. And I've got n's. Let's do those ones next. I've got 4 minus 8 makes minus 4. And then I've got v's. I've got 5 plus 2 makes 7. And that's my final answer. So we're just running across the row, tidying up the numbers, and then collecting up the indices, just using law number 1. Question 3 is a compound interest question. So we've got a formula for this one. It is that the account balance is going to be the principal amount multiplied by 1 plus the rate over, and the indice becomes the number of compounding units. So if you are unfamiliar with this, go back and watch the fundamentals video. I talked about this a bit. In question 4 in a minute, we'll really have to narrow down the rate and the n value, but for this one we'll just see how we go, substituting straight in. So we need to know what A is, P is, R is, and N is, so that we know what we're doing before we start. So let's work this out. We have got the account balance at the end, so we've got 5,500. So that's this one here. This is what happened at the end. What else have we got? We've got the principal amount. That's the amount that they started with. So they had a $3,000 investment. So this is 3,000. We've got no, we're missing the rate. Okay, so that's what we need to find out. And we've got a time here. We've got 6 years. Now be careful, and I'll talk about this more in the next question, but you've got 6 years that compounds annually. And the word annually means once per year, okay? And that will become quite important. All right, let's do this. We've got A. Oops, we already know what A is, so let's fill it in. We've got 5,500, and that equals the principal of 3,000. Probably shouldn't put commas in, should I? Old school. I've got 1 plus my rate, and then I've got 6 at the top here. So let's start to solve this out. I have got a bit of balance method to do here, so I'll divide by 3,000 on both sides. I'm using a calculator, and I find that that will give me 1.83 repeater, and that equals 1 plus r to the power of 6. That's not much good to me, so I'm going to do the root power of 6 to both sides to remove that. And so again, using a calculator, 1.1063 will be 1 plus r. Let's get rid of that 1. So I will take 1 from both sides, and I'll end up with 0.1063 being my rate. And remember that what that means is that the rate is 10.63%, because we always had to express our rate when using this formula as a decimal. Let's have a look at question 4. Just rub this out so we get a little bit more room over here, because it's going to get a bit tight for space. Okay, same formula. We've got A equals P, so the account balance equals the principal 1 plus the rate to the M. All right, we've got account balance, principal, rate, and number of compounding units. Right, we're looking for our account this time. Okay, we've got a principal amount of 21,000. We've got a rate. Now we need to be really careful. Our rate for starters is expressed as a percentage up here, okay? And we don't want it as a percentage. We want it as a decimal, which would be 0.065. But you have to be careful because this compounds quarterly. That means it compounds 4 times per year. So we actually have to divide this number by 4, okay? So that we can see what impact it has each time. So our rate is in fact 0.01625 per quarter. And similarly, our number of compounding units is slightly different because it also compounds quarterly. So it occurs over 5 years, but we actually have to do 5 times 4 because in the 5 years, it compounds 4 times each of those years. So our end value in this equation is actually going to be 20. So the numbers that we're working with are these, and I'm trying to find what A is. So let's have a go. We've got A equals a principal, 21,000. Brackets, 1 plus 0.01625 to the power of 20. And then I'm going to put that straight into my calculator. And the account balance after 5 years will be $28,988.82. So it's easy work in the calculator, but you have to make sure that you manipulate that R and N value before you start. Question 5. Now what we've got is we've just got straight index law, but these look pretty messy. So first of all, what I do when I do these is I scan across top and bottom, make sure there's no divided bys hidden in there. I like to see them all as times's, and then I work across the 2 rows. Plenty of ways to do this. This is just how I do it. Collect your numbers first across the top. I've only got 2s and 1s, so 2. And then I go through and work out my numbers. So I've got C's here, and I've got 1 here, and I've got 5. So that makes 1 plus 5, C to the 6. I've got D to the minus 4 plus minus 7 makes minus 11. All over, collect my numbers. I've just got 1 and 4, so 1 times 4 makes 4. And then I'm going to have a look at my C's. I've got a minus C here, minus 3, so I've got a C to the minus 3, and I've got a D to the 3. And then what I do in the next move is I move everything up into one line. I don't move numbers though. Don't ever move numbers. Just simplify your fraction and everything stays as it is after that. So I've got C to the 6 up here. I've got D to 11, minus 11. And then remember, when I bring up that C to the minus 3, it becomes C to the positive 3. And when that d to the 3 at the bottom comes up, it comes d to the minus 3. And by doing this, I'm just back to index law number 1. So 1 over 2. I've got c to the 6 plus 3 makes c to the 9. I've got d to the minus 11 plus minus 3 gives me d to the minus 14. It's a very funny looking 4. And then just to tidy this up, because the question says that I have to write it with positive indices, I've got to send that d down. So it becomes c to the 9 over 2d to the 14. There's a little 1 here, but I don't bother writing it. And that's my final answer. Next one. As I scan across the next one, I see divides. I don't want to see divides. So the first thing I'm going to do with this one is get rid of that divide. And I can do that if I just change it into a times and make this one negative. Then I can just run exactly the same process as what I did in the question A. So let's work across the top. I've got 5 times 6 makes 30. And I've got some values of d there, so I've got, try that d again, don't want to confuse anyone, so d to the minus 4, there aren't any others. I've got m's, so I've got m to the 1, 1 minus 3 makes minus 2, minus 2 plus 1 makes minus 1, and then I've got a to the minus 2, all over. 7 times 2 makes 14. I've got d's down the bottom as well, so I've got 1 minus 9 makes minus 8, and then I've got m to the minus 7. Excellent. Simplify the fraction if you possibly can. So I can see here the equivalent fraction would be 15 over 7 because 2 goes into both those numbers. Start writing out your top line. D to the minus 4, m to the minus 1, a to the minus 2, and now bring your values up from the bottom. So d to the minus 8 becomes d to the positive 8, m to the minus 7 becomes m to the positive 7. Back to index law number 1. Right, let's start with, I'm going to do it in alphabetical order, but you can do it in any order you like. I've got an a to the minus 2 there. I've got d, so I've got minus 4 plus 8 makes positive 4, and then I've got m minus 1 plus 7 makes positive 6. So the only indice that's negative there is that a, so I'll send that down. So it will become 15 over 7, d to the 4, m to the 6, over 7a to the positive 2. And that's my final answer in positive index form. Question 6. We're back to our compound interest formula. So we're back to a equals p outside of 1 plus r to the n. Let's see what values we've got and which values we need. We've put them down here where we won't get lost along the way. So we've got the final account balance. So we've got 52,120. We don't have our principal. That's what we seem to be chasing. We've got a rate of 5.25%. Be careful, it needs to be moved into a decimal. And if we go and look closely at this investment is 3 years and it compounds monthly. That means that we've got to divide this number by 12. If there are 12 months in a year, so we want to see what the interest is doing in each of those months. So that will give us a value of 0.004375. I'm carrying quite a lot of decimals here. I'm going to try and limit my error. And then I've got a number of compounding units. be careful, it is 3 years, but remember it compounds monthly and there are 12 months in a year, so my end value is in fact 36. So the numbers we're working with are these ones. Let's sub it into the formula and get an answer. So I've got an account balance of 52120, and that equals the principal, which is what I'm chasing, and then I've got 1 plus 0.004375 to the power of 36. And so I'm going to do a little bit of work with my calculator here. I've got 52120. What I might do is just to keep this nice and accurate is I might divide everything on this side, on both sides, sorry, by the 1.004375 to the power of 36. Okay, so I might do that to both sides. That way, I can put it straight into my calculator without making too many rounding errors. If you're not too sure what I'm doing here, just stick to the balance method. Just plug it into your calculator and deal with any small inaccuracy. And so once I've dialed that into my calculator, I'll find that the principal, and it's a worded question, so I should answer this properly. The principal amount was $44,540.21. That's the final answer. Question 7, just make us a bit of room so we don't get confused. Okay, we're back to another compound interest formula, so same formula. But with a little bit of modification this time, because if you have a quick read, it tells me what, whoa, crossing out the question, it tells me what the interest was. And up until this point, we haven't really looked at the interest. So we better have a think about what that is. If you invest a principal amount and then it grows to your new account balance, remember that the difference between these A minus P is the amount of interest. So it's the amount of extra money that you've got in the account at the end of an investment, or if you've borrowed money, it's the extra amount that you'll have to pay back. So we're going to need to modify our formula a little bit. We might write it as the interest is going to be the account balance. So that's this. Oops. The formula that we've been using. I'll try and make this nice and clear for you in a second. Okay, so if we think about this, A equals this in the formulas that we've been using. So all I'm saying here, and I'm doing this, is I'm modifying the formula a bit so that the interest here equals the A minus the P, and that's what I'm saying here. The interest equals the A minus the P. So what I'm trying to do is say that if I work out what the new account balance is and I take away the amount that I originally put in there, then I'll find out what the interest is. So I've got I, P, R, and N. My interest, I know, that was 8,225. My principal is what I'm trying to find because it's asking for the original investment, and that is the principal. My rate, I'm going to have to modify because it's in percentage form, so I want that as a decimal. And I'm going to go back and check the question because although it is for 8 years, it compounds quarterly, and it does that over 8 years. So this value here, I'm going to have to divide by 4 because it compounds 4 times per year. So that's going to give me a modified value of 0.01275, carrying plenty of decimals again. And then my number of compounding units is going to be my 8 years, but it does that 4 times per year. So that's going to have a new value of 32. So these are the numbers that I'm working with. All right, let's sub them in and solve. So I've got an initial investment of 8225. I don't know what my principal is. I know what my rate is. I know what my n value is. And I've got another principal hanging off the end there. It's going to be a little bit tricky with 2 p's in there, so what I'm going to do is I'm going to factorize this. So I'll keep this the same, but I can see that there are 2 p's there, so I'll take p out the front of, and I'll give myself a giant set of square brackets here, because that applies to this 1.01275 to the power of 32, and it also applies to that p on the end, so that can become a 1, because p times minus 1 would make minus p. Alright, now we've got to this point, we can start to use our calculator a bit. So I've got an enormous yellow box in the middle of my maths. I've got 8225 equals p times and 0.49993 using my calculator there. And then I'm going to use a little bit of balance method just to tidy it up at the end. So I'll get rid of that by dividing both sides by 0.49993, and I will have a principal investment of $16,452.30. And that's my final answer. 1 to go. We're going to do some graphing this time. And we've got a new word to learn, which is this one as asymptote. Now, an asymptote is something we're going to have to mark on this, so I'm just going to start by marking this. The asymptote occurs up here. See how it's got a constant on the end of -9? Now, this has got an asymptote because this graph is going to be exponential. You notice how here we usually have x to the something, and there's a number at the top, but this time we've got an x as the indice. When that happens, we get something called an exponential. And then this value on the end here, which is our constant, becomes the asymptote. So when you go to mark this on the graph, put yourself a dotted line in where y equals -9. So if I give this graph a scale, so this has got some reference, that's -10, this is +10, +10, -10, this is my x-axis, this is my y. The asymptote is the line that our curve will never quite touch. It will get incredibly close to it, so it's going to look something along these lines by the time we're finished, okay? And down here, it's going to get awfully close to touching that asymptote. It will get increasingly closer and closer and closer, but no matter how far it goes, it will never quite reach that point, okay? So let's finish marking our asymptote. We're going to say an asymptote of -9. And now what we're going to do is we're going to plot this. Now, we haven't done a lot of these, so a nice, easy way to do this would be to draw ourselves up one of those tables. And so we'll give ourselves a bit of a grid to work with here. Give ourselves X and Y values. This way we can plot them as coordinates. And let's go for start at 0. Hopefully we won't have to go too far into those negative numbers there. And I'm going to get you guys to do the same thing as what we've done back in the fundamentals. Get your calculator all set up so that you can just sub these values in, okay? So you're going to set your calculator up so that you've got some brackets up here to change this value, and you'll be able to just sub these values in. So we'll start at 0. I like to start at 0. It's nice and clear. So if I make that 0, I'll get -8. And I'll change this to 1. And I'll get the value -6. And then I'll put in 2. And I'll get the value 0. That's going to be a good one. That'll be our x-intercept. And then I'll put in 3. And that'll give us the value 18. And let's just go back and test -1 and see what happens. And we'll get -8 2/3. Okay. Let's have a look at plotting some of these. So I can see there's some important points here. I've got a y-intercept here at 0, -8. I'm going to mark that one in as well, okay? It wants me to mark in both intercepts and one other random point. So let's mark in our intercepts first. I can also see that when x is 2, y is 0. So this is another good one. I'm going to mark that one in. And then 318 is not going to fit on the graph, so the only other logical one to choose, I guess, is 1 and -6. So let's mark that one in as well. So we've got one at 1, -6 here. And it's going to be quite hard to get this last one in, but -1 and 8 2/3 is going to be down here somewhere. And then when you go to draw this curve in, it's fairly hard to draw. Don't use a ruler. Freehand it as best you can. Don't let that line touch the asymptote. It's going to come up like this and go up exponentially. Put an arrow on each end because it goes forever in each direction. And that one has been drawn. It's going to be exponential. You notice how here we usually have x to the something and there's a number at the top, but this time we've got an x as the indice. When that happens, we get something called an exponential. And then this value on the end here, which is our constant, becomes the asymptote. So when you go to mark this on the graph, put yourself a dotted line in where y equals -9. So if I give this graph a scale, so this has got some reference, that's -10, this is +10, +10, -10, this is my x-axis, this is my y. The asymptote is the line that our curve will never quite touch. It will get incredibly close to it. So it's going to look something along these lines by the time we're finished. Okay. And down here, it's going to get awfully close to touching that asymptote. It will get increasingly closer and closer and closer. But no matter how far it goes, it will never quite reach that point. Okay. So let's finish marking our asymptote. We're going to say an asymptote of -9. And now what we're going to do is we're going to plot this. Now, we haven't done a lot of these, so a nice, easy way to do this would be to draw ourselves up one of those tables. And so we'll give ourselves a bit of a grid to work with here. give ourselves x and y values. This way we can plot them as coordinates. And let's go for start at 0. Hopefully we won't have to go too far into those negative numbers there. And I'm going to get you guys to do the same thing as what we've done back in the fundamentals. Get your calculator all set up so that you can just sub these values in, okay? So you're going to set your calculator up so that you've got some brackets up here to change this value, and you'll be able to just sub these values in. So we'll start at 0. I like to start at 0. It's nice and clear. So if I make that 0, I'll get -8. And I'll change this to 1. And I'll get the value -6. And then I'll put in 2. And I'll get the value 0. That's going to be a good one. That'll be our x-intercept. And then I'll put in 3. And that'll give us the value 18. And let's just go back and test -1 and see what happens. And we'll get -8 2/3. Okay. Let's have a look at plotting some of these. So I can see there's some important points here. I've got a y-intercept here at 0, -8. I'm going to mark that one in as well, okay? It wants me to mark in both intercepts and one other random point. So let's mark in our intercepts first. I can also see that when x is 2, y is 0. So this is another good one. I'm going to mark that one in. And then 318 is not going to fit on the graph, so the only other logical one to choose, I guess, is 1 and -6. So let's mark that one in as well. So we've got one at 1, -6 here. And it's going to be quite hard to get this last one in, but -1 and 8 2/3 is going to be down here somewhere. And then when you go to draw this curve in, it's fairly hard to draw. Don't use a ruler. Freehand it as best you can. Don't let that line touch the asymptote. It's going to come up like this and go up exponentially. Put an arrow on each end because it goes forever in each direction. And that one has been drawn.